All right, folks, we're going to cover 4.3 today, which talks about measures of relative position. It's really like what it sounds. We are going to talk about different measurements, specifically today percentiles, but it measures how a person does compared to a like group. So an example they give you here is if we want to talk about like an ACT or an SAT, okay, sometimes they report back not necessarily just your score, but then how you scored compared to other people as a percentile. So suppose you could have scored at the 80th percentile, and that means you did at or above 80% of all the other people who took that similar test, okay, so in the same group. So another one, and this kind of really goes with the definition, but another one here gives you a specific example with the 30th percentile. It's about 30 are below it, and it's really at or below. Okay, so I would like you to add here percent that fall at or below the given value. Okay, because that's how we're going to interpret it as we go through here. So percentiles are just a location. If we think about putting all of the test scores in order, we figure out where we rank in terms of all the total test scores, however many they were, and just write it essentially as a fraction that we convert to a percent. What you're always going to see, though, is percentiles recorded as a whole number, so we may have to round. I'm actually going to kind of skip over most of this other than we are going to order it. That's going to be our first step. But as far as this part goes, we're going to just do some examples and we'll see kind of how this works. And I do it just a little bit differently than the book does, so we don't have to worry about different rules for rounding. Okay, so let's look at this first example. We've got 40 members of the company giving a screening test for a new position, and their scores are reported below. To inform potential employees of their screening test, you want to report these as a percentile for them, rather than just giving them their score, and they may not know what that means, if they did overall well or overall not so well. Okay, so it asks us for the 10th and 88th percentile for the test. What we're actually going to do is find all of them. Okay, so how this works for every single one is we are going to first sort the data if it's not sorted for us. So in this case, it looks like it's sorted for us, but it's kind of chaotic here. It's in a table of values versus a row. And in this case, it doesn't super matter, but we do need to figure out how many total there were. And there were 40, so we already know that. Okay, what we're going to practice is doing this when we don't have that information. So what we're going to do is copy all this over, and if we want to use like the transpose or copying the features so we can sort them, we have to make sure that we do a copy and paste one column at a time or one row at a time. You cannot use the transpose function if you have to sort it. So even though these go in order from rows, I'm going to go ahead and copy them in columns and then just resort it. Okay, so each one of those just copy over, Control-C, Control-V, so that we have them in a nice long column. There's 40 numbers, so it's going to go down a ways, which is just fine. Okay, it's good practice for when they're not in order for us. Once we've got them all copied into a column, highlight the whole thing, and we'll resort them since we copied by column instead of row. Okay, remember that is under just this sort button, and we want smallest to largest. Okay. From there, I'm going to have to copy and paste these over. I got them in a merge cell. Okay, so if you did that same thing, you should be able to fix it just by moving it over. And now we can see that they're actually in order from smallest to largest all the way down. Now we already know that the numbers are 1 to 40, but here's what I want you to do to the side of your table always. Just do a 1, 2, and as soon as you have that pattern, you can highlight it and fill it down so it numbers each individual for us. The reason this is important is because we're talking about percentiles, which are a ranking system. Okay, this highest score is 40th in line, And normally 40th would seem like last, but how we calculate percentiles are thinking about their percent out of a total. If we think about 40 over 40 as a total, that's 100%, which is the best percent or percentile. Okay, so now that we've done that, and we know our total is 40, we're going to go back to the beginning, and this is going to be our percentile column. Okay, so this one is our original data, and this was just our rank value. So to find our percentile, we take the rank value over the total, and I'm just typing it in, that way I don't have to do an absolute cell reference, and we can now drag that whole thing down. And we can see that last one is 1. We're going to go up to our formatting, change them all to percent, and there are the different percentiles. Here's the weird part though. There's one more step, and this is what we have to use that at or below definition for. We want the percent that fall at or below the given value, and if we look at this first couple, 18 is just fine, but here, this 2121, that's the same score, but it's giving different percentiles. If we want at the percent at or below, we want to always go with the highest percentile, which means this 5% will just go away. And we're going to look for repeats all the way through. Anytime there's a repeated value, you're going to keep the higher one and ditch the smaller one. Okay, so all the way through, just repeating that process. There's a repeated again, which means not all percentiles exist, 1 through 100. Unless you have over 100 unique data values, it's actually not uncommon to not have percentiles exist. And it looks like that is all of the repeats. So we were asked to find specifically the 10th percentile. Okay, our 10th percentile did exist. Okay, so our 10th percentile was the 27 score, and it did not tell us what these were represented as, so I'm just going to say points. And our 88th percentile, we'll do the same way, we'll just look for that 88 in our table, and that went with 71. Again, I'll just put points because it didn't tell us what they were measured in here. And that's it. Okay, so we're just going to practice doing the same thing. Okay, there's 2 different ways I can ask you questions. I can ask you, find the 10th and 88th percentile and report one of the individual numbers, or I could say, here's a number that's in your table, give me the percentile that goes with it. Either way, we're going to set up a table the same way we just did that one. Okay, so this one will be the same process. We're going to copy and paste these into a big column here. Control C. All the way through here. Now, if your data is small enough, sometimes it's to a place where you can actually just count. Like, by looking at it, I know that this last value is the only value that is 9.2, okay, because they are in order here. And it's the last one. If you count all these, there are 20 different values here, so this would be the 100th percentile. Now, I will tell you sometimes when we talk about percentiles, they don't report 100 as 100. Sometimes they'll call it the 99th percentile. But for me, we're just going to round to the nearest whole number, and Excel does that for you if you change it to percents. Okay? So we've got this. Then we need our ranking. 1, 2. Okay, just fill it down all the way to the bottom. That also tells you that 20. And then we're ready to find the percentile. It's equals rank over total, and we know our total is 20. Fill it all the way down. Change that to a percent, and then answer some questions. Okay? Remember, if there are values that repeat like here and here, we got to delete out the lower ones. 7 is repeated. 8.3 is repeated, just the lower one, because at or below has to be the same value. So this value, we're giving them the higher score, getting rid of the lower one. So it says, what is the 75th percentile? We're looking for 75. That's 8.2. And we just go back to our label here. It's talking about pounds. So that would be 8.2 pounds. 50th percentile. That one does not exist because that 7 and that 7 are both at the 50th. So you're just going to say there isn't one. That's a thing. Okay? Now we're going to go backwards. That's what I was talking about. You can answer questions going both directions. So this one says, find the percentile of a weight of 8.3. So 8.3, there were two different values, and you want to make sure you go with the higher one. We already deleted out the other one. So this one, it says, find the percentile. You're going to say 85th percentile. And what we're going to do for these ones is also interpret what that means based on our definition. So this means that about 85%, our context was talking about the weights of newborn babies. So about 85% of newborn babies weigh at or below 8.3 pounds, because that was the value that we were given here. All right, then it says 6.6, same thing. We're going to our table. This one goes with 40%. So this is the 40th percentile. And again, this means that about 40% of newborn babies weigh at or below, this time, 6.6 pounds. That's really it with percentiles. Okay. The other thing we're going to talk about are box and whisker plots, because they're also dealing with points of location. Okay, hopefully you remember from Algebra 1, and I think you did it again in Algebra 2. Box and whisker plots are comprised of 5 numbers, the minimum, the maximum, and then in the middle is the median, and quartile 1 and quartile 3 are just the median of the lower half and the median of the upper half. Now, as this relates to percentiles, is quartile 1 is about the 25th percentile. Now I say about because remember the 25th percentile doesn't have to actually exist. If I go back to this table, I didn't have a 25th percentile. I didn't have a 50th. But quartile is about a quarter of the data, so that's where these values come from. Median is about halfway through. There's 50% below, 50% above. But we know repeated values are going to skew those percentiles because we want to make sure that you're getting the most for your money at or below, okay, when we calculate those percentiles. So this is just an approximation. Keep that in mind as you answer questions on Hawks. Okay. Interquartile range is just the length of the box. Okay, but it's quartile 3 minus quartile 1. Okay, that's the edge of the box values. And then sometimes outliers exist. We'll get to this math as soon as we look at an example. Okay, so your first step to do a 5-number summary to get all of these values is to put your data in order. Okay, it looks like ours is already sorted for us, so that's good. And then we're going to start with just labeling min, Q1, median, Q3, and max. Okay. If we have a large set, equals min, remember, is something you can do. In this case, if you've got it in order, you can just grab the minimum. It's right there. Same thing goes for your maximum. Okay, we know our maximum is 54, but you can also use the formula if you've got a large set that maybe is in a table versus in a nice line like this one. Okay, we're going to do median next, and it's really important that you do it next after min-max. Okay, so this one equals median. Okay, remember when we're calculating a median by hand, it's just finding the middle value. Okay, what I'm going to have you do is once you find the median is pull it down. it's going to give us some guidance, because when we find quartile 1, it is the median of all of these values below, so it tells us just go to the left of that value. So do equals median, and then highlight everything to the left. Same thing goes for quartile 3. You're going to do equal median, and then highlight everything to the right. You are never including the median. Okay. We have our summary. We just have to add context. It says this is the ages of teachers in the math department at Big High School. So this is years old for all of these. Okay. All right. So in this case, it doesn't appear that there are outliers, because this 25 is pretty close to this 31, and this 50 is close to this 54. But we're going to talk about how to determine mathematically. So to the side here, I want you to put a low and a high. And what we're going to do is fill in this boundary. So equals, you're going to just follow the formula. It says take Q1, so we're grabbing that number, and then say minus 1.5, and it's times the IQR. An interquartile range is just the distance between these two values. Okay, mathematically you can just subtract them, or you can physically do the subtraction here. We know it's Q3 minus Q1, so you can physically grab Q3 minus Q1 and make it do all the work for you. Okay? Same thing goes for the high side. We're starting at Q3 because we're on the right side of the box. Okay, remember a box plot, and you can sketch this on here. It looks kind of like this thing. Okay, this is your min, Q1, median, Q3, and your maximum. So we're saying Q3 going this direction, Q1 going that direction. That's why we're subtracting. And it's basically saying we don't want these whiskers to be too long. They can't be more than 1.5 times the length of the box. Okay, so equals Q3, just grab it, and then plus 1.5 times, again, just do Q3 minus Q1. A lot of times what I'll do to the side here is just write the IQR, and let's go ahead and do that now. And do equals that Q3 minus Q1. Again, you're always welcome to just do the math by hand if it's this obvious from 13 to 49. Okay, we didn't have to necessarily use this. But this says any number that would be outside that range would be an outlier. Okay, all of our numbers fall between. So to the side here, all our numbers fall between 16.5 and 68.5. So there are no outliers. If we had a number above that 68.5 or below that 16.5, they would be considered outliers. And we'd hope people wouldn't be those ages teaching anyway. Okay. All right, so the last two questions are just review of all that stuff that we were talking about. Okay, I would like you to pause the video and try to answer those questions for me. Okay, for this one, you were just look and get. All of these are points. Make sure you put that to the side. Okay, the low end and high end tell you that this 30 really was an outlier because it was larger than 29. Okay, remember the math for that is Q1 minus 1.5 times the IQR, and for the high end, Q3 plus 1.5 times the IQR. Okay, 5-number summary, min through max. This time the median fell between two values, which happens. That's not an ACT score that's possible, but it was between those two values, which means to find Q1, you're going to take the 24 on for the median, and then same thing on the other side, that 25 on going the other direction. Okay, same process for low-high. There were no outliers in that case. Okay, with your rankings, make sure that you number 1 through 30 and delete any repeats so that your percentages always go with the highest of the values. So there were 4 20s, and we used the highest one to calculate the percentile. So the 17th percentile went with 18, so about 17% of those ACT scores fell at or below that score of 18, and there was an 80th percentile with a score of 29. And that's it.